Certainly, let's delve deeper into the intricacies of dopamine, its pathways, its broader physiological and psychological impacts, and its relevance in various medical conditions. Dopamine pathways in the brain. Dopamine operates through several major pathways in the brain, each serving distinct functions. 1. Mesolimbic pathway. Function. Often referred to as the reward pathway, it's central to motivation, pleasure, and reinforcement learning. Components. Connects the ventral tegmental area, VTA, to the nucleus accumbens. 2. Mesocortical pathway. Function. Involved in cognition, executive functions, and emotional regulation. Components. Runs from the VTA to the prefrontal cortex. 3. Neurostriatal pathway. Function. Crucial for movement and motor control. Components. Connects the substantia nigra to the dorsal striatum. 4. Tuberoinfundibular pathway. Function. Regulates the secretion of certain hormones, notably prolactin. Components. Extends from the hypothalamus to the pituitary gland. Dopamine's role in medical conditions. 1. Parkinson's disease. Overview. A neurodegenerative disorder characterized by motor symptoms like tremors, rigidity, and bradykinesia, slowness of movement. Dopamine's role. Caused by the degeneration of dopamine-producing neurons in the substantia nigra, leading to reduced dopamine levels in the nigrostriatal pathway. 2. Schizophrenia. Overview. A mental health disorder marked by delusions, hallucinations, and cognitive challenges. Dopamine's role. Hyperactivity in the mesolimbic pathway, excess dopamine, is associated with positive symptoms, e.g. hallucinations, while hypoactivity in the mesocortical pathway, reduced dopamine, is linked to negative symptoms, e.g. apathy. 3. Depression. Overview. A mood disorder with persistent feelings of sadness and loss of interest. Dopamine's role. Dysregulation of dopamine, especially in the mesolimbic pathway, can contribute to anhedonia, inability to feel pleasure, observed in depression. 4. Attention deficit, hyperactivity disorder, ADHD. Overview. Characterized by inattention, hyperactivity, and impulsivity. Dopamine's role. Altered dopamine transmission, particularly in the prefrontal cortex, affects attention and executive functions. 5. Addiction. Overview. Compulsive engagement in rewarding stimuli despite adverse consequences. Dopamine's role. Addictive substances and behaviors can cause excessive dopamine release in the mesolimbic pathway, reinforcing the addictive behavior. Factors influencing dopamine levels. 1. Diet. Tyrosine-rich foods. Dopamine is synthesized from the amino acid tyrosine. Consuming foods like almonds, bananas, avocados, and chicken can support dopamine production. 2. Exercise. Regular physical activity boosts dopamine levels, enhancing mood and motivation. 3. Sleep. Adequate sleep maintains optimal dopamine receptor sensitivity. Sleep deprivation can reduce dopamine availability. 4. Stress. Chronic stress can deplete dopamine levels, leading to mood disturbances. 5. Substance use. Drugs like cocaine and methamphetamine can artificially elevate dopamine levels, leading to neuroadaptations and potential dependence. Naftibarast. Dopamine and behavior. 1. Risk-taking. Elevated dopamine levels can increase propensity for risk-taking behaviors. 2. Creativity. Some studies suggest a link between dopamine and creative thought processes. 3. Social behavior. Dopamine influences social interactions, with impacts on extroversion and social motivation. Pharmacological interventions. 1. Levodopa, L-Dopa, used in Parkinson's disease to replenish dopamine levels. 2. Dopamine agonists, mimic dopamine action by stimulating dopamine receptors. 3. Dopamine antagonists, block dopamine receptors, used in treating schizophrenia and other psychiatric disorders. 4. Reuptake inhibitors. Medications like bupropion inhibit dopamine reuptake, increasing its availability in the synaptic cleft. Understanding dopamine's multifaceted roles offers insights into human behavior, mood regulation, and the pathophysiology of various diseases. Ongoing research continues to unravel its complexities, paving the way for targeted therapeutic strategies.
Dopamine is a neurotransmitter, a chemical messenger in the brain that plays a key role in many essential functions, including movement, motivation, reward, and the regulation of emotions. It is often referred to as the feel-good neurotransmitter because it is heavily involved in the brain's reward system. Effects on the person. 1. Motivation and reward. Dopamine is crucial movement. Dopamine helps regulate movement and coordination. A deficiency in dopamine can lead to motor control problems, as seen in Parkinson's disease. 4. Learning and memory. Dopamine plays a role in the brain's ability to learn and remember. It helps reinforce actions that lead to positive outcomes, making it easier to recall and repeat those actions. 5. Addiction. Because dopamine is linked to the reward system, it plays a significant role in addiction. The pleasure associated with certain substances or behaviours can cause the brain to crave them, leading to addictive behaviours. Overall, dopamine's influence on motivation, mood, and reward makes it a critical factor in how we feel, think, and behave.